Welcome to 5G Technology World. I'm site editor Martin Rowe. Qualcomm, Ericsson, and others have been doing some testing of millimeter wave transmissions at various locations throughout the world. One such test conducted in Rome used a CPE, customer premise equipment, from Casa Systems to demonstrate a 1 gigabit per second millimeter wave link over a distance of 6.5 kilometers. To find out more about how that was conducted, we spoke with Gautam Shioran, Senior Director of QCT Chipset Products at Qualcomm. Gautam, can you tell me a little bit about the test setup that Qualcomm, TIM, and Ericsson did? There was a test in Italy where you were able to get at I believe it's a 6.5 kilometer distance and reach 1 gigabit per second using 5G millimeter wave. Is that correct?
That's correct.
Okay.
Yes. So yeah, it was a test in Italy where we reached 6.5 kilometers and with more than a gigabit of data rate over millimeter wave fixed wireless access solution. The test setup was on the UE, on the device side, we had our X55 modem RF solution. It was incorporated in a CPE or a fixed wireless access device from Casa Systems. The network provider was Ericsson, and obviously we partnered with Tim to get this this entire setup working end to end.
Was the base station that you used already in operation, or was it deployed specifically for this test?
So this currently, we're using it for a test. It's, I believe it's a commercial Ericsson base station that we repurposed for using it for this particular millimeter wave test setup.
On the CPE side, how much power was needed to achieve the 6.5 kilometers at 1 gigabit per second?
So on the base station side, Ericsson would be the best to comment on details on the base station. On the CPE, I can talk about the CPE side. So okay. Our X55 solution, which uses the extended range antenna modules QTM527, provides a power class 1 support on the uplink. So power class 1 by definition in 3GPP is 40 dBm EARP. On an actual operation, we go beyond 40 dBm. So it's pretty powerful to provide this kind of a range and close the link in the uplink specifically at, say, 6.5 kilometers or even more.
Which millimeter wave frequencies did you use? And did you use beamforming to connect the CPE and the base station?
This was more like a range and performance demonstration of the technology, right? So it was just one user. So we used beamforming, but it was really aligned very well. Especially when you go to these long distances, you want the base station as well as the device to be very closely aligned to get multi-gigabit performance.
How did you measure the data rate?
So we have our own tools. So on the Qualcomm side, we have our test tools that our developers use, testing use, which we use to calculate the bitrate. Ericsson has their own set of tools that they use to calculate the bitrate on this.
The throughput tests, were they simply a matter of measuring bits as in bit error rate, or were you using it more as a test of throughput going up the protocol stack?
I think the multi-gigabit rate that we are doing, it's really, we typically do a test at the UDP layer. So we go up the stack to see what an actual user will get from a throughput perspective. Yeah.
The photo that came with the press release for this announcement showed a line of sight setup from the base station to the CPE. In your testing here or in other areas of the world, did you do any non-line of sight? Did you do any kind of testing that was in inclement weather or did you lower the power to see how that would affect the bit rate?
The test in Italy specifically was just focused on range, right? Getting how far we can get. And funny enough, sometimes we have problems getting cell sites that can allow us to go to 6.5 kilometers per second. So that was really the focus. But we have been doing a lot of testing, a lot of it in Australia, a lot of it in US also. And in those test scenarios, sometimes we are doing range testing, sometimes we are doing non-line of sight, suburban kind of deployment scenarios. So we are testing under various deployment scenarios as well as weather. Recently, I don't know if you've seen the latest from Mike Thaelander. I think he did some testing in US cellular network. He posted it on LinkedIn, I believe. And a lot of it was non-line of sight. And still, I think his conclusions were multi-gigabit speeds in many, many cases, even in non-line of sight scenarios. There is a trade-off. I mean, if you go long distances, let's say you're going 6.5 kilometers or longer, the best environment conditions help, right? Line of sight, sunny day, they definitely help. But really what our focus is to make sure that we can go the range, but we can also provide a solution that provides a very robust millimeter wave fixed wireless access solution for a couple of kilometers. It can be less than 6 kilometers. It can be 2 to 4 kilometers, whatever, and sometimes non-line of sights, but always providing multi-gigabit services. Yeah.
So some of this testing that you've done around the world, does it give any indication of bit rate versus distance? For example, if you were closer than 6.5, would the bit rate go up? If you were beyond 6.5, might the bit rate go down?
Yeah, so we have, we have done testing at multiple distance levels, right? 2 kilometers, 4 kilometers, and yes, the closer to the base station, you see a higher rate, right? Data rate that can be served to the users, and with distance, it does come down. So it's really a function of the data rate, and the downlink is a function of a couple of things. First is how much spectrum are you using, right? Whether you're using 400 megahertz or 800 megahertz. Second is what is the transmit power level at the base station, because that could also impact the watts you can put out per carrier, and what is the data rate you can get in the downlink, and the range, right? And the distance. So basically, yes, closer to the cell, up to 2 kilometers, we have seen more than 2 gigabits per second, right? 2 to 3 kilometers. And as the distance increases, rates come down, yes.
This test used a direct line of sight setup. Can you comment on other kinds of setups that you envision being used in the real world?
We've been looking at this area for a while. There is no single deployment scenario that is applicable to all operators. So for example, you might have a rural deployment scenarios where you want to go the distance, right? You have 4, 5, 6, or even more kilometers, where the best installation scheme to use is really a rooftop installation. So you're above the tree line, you get a direct line of sight, and you can actually go the distance. And this deployment model is not unique to millimeter wave, right? Even on a sub-6 or LTE fixed wireless access deployments, if you want to go the distance, you do outdoor roof mount installations. So that's definitely one of the scenarios. And that's, depending on how you install it, you can make sure there's no tree line interfering with your system. But we are also working on devices that go, for example, outside your house wall. We call it outdoor units, or outside your window. So these are window mount units for millimeter wave. A window mount unit obviously prevents the losses due to the window itself, the glass losses, right? So it provides a better performance. And then you run an Ethernet cable inside the house. And then we are also working on indoor millimeter wave fixed wireless access products. So stuff that could go, for example, very near the window inside the house. And these are easier to install. In many cases, it's self-installable, but it does have a window loss. So the places where this type of a model will be more applicable is, let's say, suburban or urban kind of scenarios. So no one size fits all. I think there's different deployment models and product types that we are working on. with our OEMs.
Have you done any testing in, I'll call it outer suburban or rural areas to see what kind of distance you get, and what do you need in terms of being able to bring this kind of fixed wireless access to the rural areas? Is 6.5 kilometers even enough, or would we need more even at a lower data rate just to make the distance between them? What do you anticipate?
So, yeah, I think this distance conversation is very interesting. If you remember in 2019, when we actually announced our QTM 527 extended range antenna module, we said that it could go up to 1.7 kilometers in range, right? And I think the industry was excited by that. So since then, we have done demonstrations at 3 kilometers, 5 kilometers, now 6.5, and we're trying to go even further. And that's really a technology demonstration of range, and it's applicable in some rural or fixed wireless access as a backhaul solution type of deployments. We are doing testing. We have done testing in US, in US Cellular's network. Some of those were rural deployments. We have gone 5 kilometers and up in those test scenarios. Yeah, so it's really, I think from a range perspective, you can go 5, 6.5 multi-gigabit. We have shown that. But also this means that when you go smaller than 6 or smaller than 5, let's say 3 kilometers or 3.2 miles, and you get a much more robust link, right? Just for line of sight and as well for non-line of sight kind of deployments, right? And that also has a lot of applicability in rural settings, because not all rural deployments are 6 kilometers, for example.
How long do these tests run? That is, how long do you spend at a given test site?
We spent more than a year developing this product, a year and a half actually. And all the testing, for example, in Italy as well as US Cellular, it's a multi-week effort to test it, to get the system up, and also to have multiple runs so that we can actually get some meaningful data out of the test. So this is not, yeah, it's a very thorough testing in terms of, and it's generally weeks.
What do you mean by meaningful data?
So essentially multiple runs to make sure that, we have a consistent experience, a consistent data read, right, across multiple runs, rather than just one point in which we get a gigabit, and otherwise it's we don't get that level of speeds. So we are also, as we do this testing, we are also tweaking the system to make sure the system gets more and more robust. So
okay. All right, Gautam, thank you very much for your time.